32:1. We have ignition, a brilliant blaze erupting with tremendous thrust propelling everything skyward in a spectacular ascent, much like those initial thrilling moments in humanity's grand voyage into the cosmos. Envision yourself standing there amid those early days brimming with boundless optimism, when every soul on our blue planet turned their gaze toward the starry night sky, hearts pounding with anticipation for a future where humankind stretches forth into the vast expanse of the universe. The atmosphere was electric, filled with cheers echoing across the launch site, the thunderous roar of machinery vibrating through the ground, and the acrid scent of rocket exhaust drifting on the breeze, all blending into a symphony of exhilaration and aspiration. On September 5, 1977, Voyager 1 lifted off from Cape Canaveral, Florida, aboard a Titan III Centaur rocket, marking the beginning of an epic journey that would redefine our understanding of the outer solar system, while Voyager 2, launched just weeks earlier on August 20th of the same year, followed a similar path but with a trajectory allowing it to visit additional worlds like Uranus and Neptune. It was precisely within this feverish excitement that a pivotal decision was made, one that, in retrospect with our delayed wisdom, appears as a latent blunder laden with peril from the National Aeronautics and Space Administration, the premier space agency of the United States. They forged a close alliance with the renowned American astronomer and foremost authority on extraterrestrial life, Frank Drake, a visionary whose eyes forever sparkled with insatiable curiosity about the enigmas of the universe. Drake, who in 1961 formulated the famous Drake equation to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way galaxy, brought his expertise to the project. Together, they crafted and affixed to the Voyager spacecraft's intricate pulsar maps, exquisite diagrams intended to guide any intelligent life beyond Earth straight to our verdant home world. Picture Frank Drake ensconced in his laboratory, the dim glow of fluorescent lights casting shadows across his thoughtful features as he meticulously sketches precise lines on parchment, while beyond the window, the silent night sky bears witness to his endeavors. These maps were far from mere dry schematics, they represented an invitation laced with hope, yet unwittingly they might consign our entire planet and species to unimaginable jeopardy. The pulsar map, etched onto the cover of the Golden Record, depicts our solar system's location relative to 14 precisely selected pulsars, chosen for their stability and visibility across the galaxy, serving as cosmic beacons much like lighthouses in the stellar sea. And then there is the Golden Record itself, a true time capsule encapsulating the essence of Earth through sounds, visuals, and melodies, meticulously curated to convey a message of peace and foster dialogue with potential extraterrestrial intelligences. Conceive of it as an exquisite gift box, sheathed in gleaming aluminum plating and inscribed with elaborate instructions and a unique galactic cartography. This diagram precisely locates our solar system against 14 pulsars, those furiously spinning neutron stars that emit rhythmic radio pulses akin to the steady heartbeat of the cosmos itself. Each pulsar is illustrated by a line radiating from the Sun, with the line's length corresponding to the approximate distance from that pulsar to our solar system, measured in light years for universal comprehension. These pulsar lines are further annotated with binary code sequences, simple yet ingenious strings of zeros and ones. Decoding these binaries and multiplying by a designated fundamental time unit yields the pulsar's rotation frequency, providing a universal clock that any advanced civilization could calibrate independently of their own temporal systems. Frank Drake's ingenious selection stemmed from his deep insight into interstellar communication, drawing from his pioneering work at the Arecibo Observatory where he first beamed intentional signals toward potential alien worlds. This method establishes a subtle bridge across the infinite void, evoking the profound wonder of science in its quest to touch the unknown, reminding us that in the silence of space, even a whisper can echo eternally. Now, delve deeper into the treasures housed within the Golden Record, a vibrant tapestry weaving the rich tapestry of life and culture on our world. It enshrines 115 diverse images, ranging from majestic natural spectacles like mighty rivers carving through lush emerald forests and snow-capped peaks piercing azure skies, to poignant human vignettes such as the joyful grins of children from every corner of the globe, families gathered in harmonious celebration, and architectural marvels including the intricate spires of the Taj Mahal bathed in golden dawn light or the bustling markets of ancient Marrakesh alive with vibrant hues. These visuals, encoded in analog form for analog playback, also include scientific diagrams like the double helix structure of deoxyribonucleic acid, the blueprint of life itself, and diagrams of human anatomy to convey our biological essence. Musical selections span eras and continents, from the haunting bamboo flute melodies of traditional Asian ensembles evoking misty mountain serenity, to the pulsating drum rhythms of African tribal ceremonies that stir the soul with primal energy, and the soaring symphonies of European masters like Ludwig van Beethoven's Cavatina from the String Quartet in B-flat major, Opus 130, which swells with emotional depth, or Johann Sebastian Bach's Brandenburg Concerto No. 2, live, with baroque precision. Even contemporary sounds like Chuck Berry's rock and roll anthem Johnny B. Good inject a pulse of youthful rebellion and innovation. Natural sounds are captured with exquisite fidelity, the gentle murmur of ocean waves caressing sandy shores at twilight, the mournful howls of wind sweeping across vast golden plains under stormy skies, the cheerful twittering of birds heralding the sunrise chorus in a dew-kissed woodland, and even the ethereal songs of humpback whales echoing through abyssal depths, a reminder of Earth's oceanic symphony. Do not overlook the greetings in 55 languages, from the warm resonance of English declarations like hello from a place of friendship, the romantic cadence of French salutations evoking shared humanity, to the affectionate tones of Vietnamese phrases carrying the intimacy of familial bonds, all serving as heartfelt overtures from the collective spirit of humankind. The eclectic curation behind this assemblage is profoundly beautiful, aiming to unveil the opulent splendor, the kaleidoscopic beauty of our planet and its kaleidoscopic inhabitants. In the year 1977, as Voyager 1 and Voyager 2 departed Earth amid the resonant thunder of rocket engines akin to rolling thunderclaps across the heavens, this endeavor was hailed as a noble and captivating outreach to the stars, a beacon of connection to distant civilizations brimming with promise. One can almost feel the elation rippling through the mission control rooms at the Jet Propulsion Laboratory in Pasadena, California, where engineers and scientists embraced in jubilant cheers, eyes glistening with the shared dream of cosmic kinship. Yet this buoyant approach stands in stark opposition to a more circumspect perspective, vividly embodied in the dark forest hypothesis, a concept that sends shivers down the spine when contemplating the universe's mysteries. Imagine the cosmos as an immense, shadowy woodland, where every civilization prowls in hushed vigilance, acutely wary of revealing itself to unknown entities lurking in the gloom. In this metaphor, broadcasting one's presence equates to kindling a campfire amid pitch blackness. It might warm allies, illuminate paths, and forge bonds, but it equally beckons predators slinking through the underbrush. From this vantage, dispatching the golden record becomes a blazing torch, blatant proclamation of our existence and exact coordinates. Rather than a gesture of optimism, it morphs into a perilous wager, quickening the pulse with trepidation. This hypothesis, popularized by Chinese science fiction author Liu Cixin in his acclaimed novel The Dark Forest, the second installment of the Remembrance of Earth's Past trilogy published in 2008, posits that in a universe teeming with life, resources are finite, and survival demands preemptive aggression against potential threats. Civilizations remain silent not out of isolation but strategic caution, akin to hunters in a perilous thicket where trust is a luxury few can afford, offering a chilling resolution to the Fermi paradox, which questions why, given the vastness of space and time, we have yet to detect signs of extraterrestrial intelligence. The notion that an alien civilization might imperil Earth draws directly from humanity's own tragic annals, epochs of conquest and colonization, where encounters between civilizations of vastly disparate technological prowess invariably culminated in catastrophe for the inferior party, evoking visions of ancient empires crumbling under invading hordes, cries of anguish reverberating through the corridors of history like echoes in forgotten ruins. Proponents contend that analogous dynamics could unfold on a galactic scale, positioning Earth as prey to rapacious extraterrestrials. The brilliant physicist Stephen Hawking, his distinctive computerized voice delivering profound insights through a synthesizer interfaced with his wheelchair, and his eyes reflecting depths of contemplative wisdom, voiced apprehensions that advanced extraterrestrials, should they exist, might not regard us with benevolence. In a 2010 episode of the television series Into the Universe with Stephen Hawking, he likened potential alien contact to Christopher Columbus's arrival in the Americas, warning that such visitors could view Earth as a resource depot to plunder, much as humans have historically exploited one another or indigenous populations. He elaborated in interviews that aliens might strip mine our world for materials, disregarding our pleas, or even colonize it by supplanting us entirely, urging humanity to withhold active transmissions lest we invite calamity. This stance casts the dispatch of messages like the Golden Record in a foreboding light, suddenly chilling the laboratory air with an undercurrent of dread. In a hypothetical scenario where the Voyager spacecrafts pose a grave threat to Earth by potentially luring hostile extraterrestrial attention, we might necessitate deactivating them or reprogramming for self-destruction. Should shutdown prove unfeasible, alternative tactics could be employed, though the immense distances complicate every maneuver. As of November 17, 2025, Voyager 1 hurtles through interstellar space at approximately 38,210 miles per hour, or about 17 kilometers per second, positioned roughly 169 astronomical units from Earth, equivalent to over 25 billion kilometers, venturing deeper into the cosmic void where temperatures plummet to near absolute zero, a frigid realm of scattered particles and faint starlight. Voyager 2, trailing slightly, maintains a velocity of around 34,391 miles per hour, or 15 kilometers per second, at about 126 astronomical units distant. To pinpoint and neutralize them demands revolutionary technologies, such as colossal telescopes sweeping the heavens or hypersensitive detectors capturing feeble emissions from these diminutive probes. One conjectural remedy involves deploying a potent laser beam to vaporize the Voyager spacecrafts, concentrating an intense light beam upon the vessels to incinerate them utterly, eradicating the Golden Record and its navigational charts from existence. Yet this method brims with hurdles, its technical viability dubious amid current capabilities, and the act of demolition might itself be intercepted by alien observers, amplifying scrutiny like a thunderous explosion reverberating through the dark forest. Devising stealthy eradication protocols that evade detection remains paramount, requiring finesse akin to shadows gliding unseen in nocturnal obscurity. An alternative strategy entails launching swifter, more sophisticated spacecrafts to intercept and disable the Voyagers. Presently, the Parker Solar Probe holds the accolade for fastest human-made object, attaining speeds of 430,000 miles per hour, or 692,000 kilometers per hour, during its daring plunges toward the Sun's corona in September 2025, shattering previous records while enduring blistering heat exceeding 1 million degrees Fahrenheit. Nonetheless, even at such velocities, it would require about 35 years to rendezvous with Voyager 1. For expedited pursuit, cutting-edge propulsion systems are imperative, such as advanced ion thrusters or nuclear thermal engines propelling vessels at breakneck paces. The Voyager probes, despite their launch nearly 5 decades ago, only recently breached the heliopause into true interstellar medium in 2012 for Voyager 1 and 2018 for its sibling, and they shall require approximately 40,000 years to approach the nearest star, Proxima Centauri. Contemplate the chasm, trillions of kilometers of inky blackness, distant stars twinkling like remote embers of possibility, underscoring the profound solitude of our exploratory odyssey. To comprehend the advancements requisite for an extraterrestrial civilization to detect, retrieve, and decipher the Golden Record, consider the sequential hurdles. Initially, they would require telescopes and sensors of unparalleled sophistication to spot the Voyager amid the interstellar expanse, far surpassing our James Webb Space Telescope with arrays magnified thousands-fold, equipped with detectors attuned to the faintest glimmers and algorithms sifting probe signatures from the cosmic din, much like discerning a whisper amid a galactic gale. Subsequently, for rendezvous, mastery of interstellar traversal is essential, technologies defying conventional physics, such as faster-than-light propulsion, though it contravenes Albert Einstein's theory of relativity positing nothing exceeds light speed in vacuum, or speculative constructs like the Alcubierre warp drive, which contort space-time via exotic matter yet undiscovered, enabling efficient transit without breaching fundamental laws. In 2025, the latest inquiries from the National Aeronautics and Space Administration and the European Space Agency affirm interstellar travel as aspirational reverie, with the Breakthrough Starshot initiative, which envisioned laser-propelled nanocrafts attaining 20% light speed to reach Alpha Centauri in 2 decades, now suspended indefinitely as reported in September 2025. Its $100 million funding exhausted amid technical impasses and waning momentum. Upon arrival, they would deploy dexterous robotic manipulators to capture and examine the Voyager intact, preserving the aluminum casing and gold-plated disc, alongside nanoscale imaging apparatuses dissecting the record's molecular composition. Such a civilization likely eclipses us by centuries or millennia in scientific prowess. Envision them as technological deities with metropolises orbiting gas giants, harnessing black hole accretion disks for boundless energy, their societies woven into the fabric of quantum realities we scarcely fathom. The prospect of such elevated civilizations inhabiting the sprawling Milky Way hinges on myriad variables, with probabilities shaped by stellar demographics. Our galaxy harbors between 100 billion and 400 billion stars, with the Gaia mission's refined data release in 2023 and subsequent updates through 2025 pegging the figure at approximately 300 billion, a luminous archipelago of suns cradling myriad planetary broods. Revelations from the Kepler and Transiting Exoplanet Survey satellite telescopes have unveiled thousands of exoplanets, many nestled in habitable zones where liquid water might flow, elevating the fraction of potentially clement worlds. Yet average separations of 4 light-years between stars render encounters sporadic, even as updated iterations of the Drake equation, refined in 2024 to incorporate the fraction of habitable planets developing communicative life as a dual term for origin and endurance, suggest thousands of contemporaneous civilizations might thrive, tempered by the brevity of societal lifespans ravaged by conflicts or cataclysms. Though the odds of unearthing the golden record remain slender, the apprehensions underscore the perils of broadcasting our presence. Notwithstanding these cautions, a cadre of scientists persists in advocating novel transmissions. The Message in a Bottle initiative, a contemporary endeavor to dispatch encoded missives toward exoplanets like those orbiting Proxima Centauri, embodying humanity's indomitable urge to extend tendrils into the void. Detractors, invoking the precautionary principle, admonish that divulging Earth's particulars risks exposing us to inscrutable motives, advocating restraint until scientific consensus coalesces on interstellar etiquette. This debate, amplified by messaging extraterrestrial intelligence efforts in 2025, including proposals for artificial intelligence-mediated dialogues to bridge linguistic chasms, highlights the tension between curiosity and caution. The Voyager spacecrafts and their golden record epitomize our inquisitive spirit, yet they also serve as stark admonitions of latent hazards and looming challenges ahead, akin to a flame flickering in the shadowed woods, offering solace and peril in equal measure, compelling reflection on humanity's diminutive yet audacious niche within the boundless cosmic tapestry.